In your homework 5, you will be asked to implement the language Lambda E. So in this following slides, I'm going to introduce this language, where we finally implement defines in an more accurately with respect to Racket. So the novelty will be, the language is very similar to Lambda F, except to how we handle environments. And to that end, there are basically two operations that I need to introduce, which are going to mutate environments in two different ways. So one is we need to have a way to mutate an existing environment. So think of heap put. Okay, so recall we learned about heaps. And in heaps we learned that there were you could do three things in heaps, right? You could allocate a value, you could update a current value with put, and then you could get the contents of a variable, right? So you can do all these three things in a shared memory heap. So those three notions are going to be show up here as well in language Lambda D. So let's look at how they will show up, and they will show up in red. So red is basically operations that are mutating. They are mutating this shared memory, which is encoding mutation, right? So let's see. First, I'm going to explain the intuition behind the two rules, and I'm going to cover first terms and then expressions. And for now, for terms, I'm going to explain the two rules, the intuition behind them, and then I'm going to go item by item, explaining what each rule is doing. Okay, so the idea behind define, let's start from sequence. The idea behind sequence is that it's very similar to Lambda F. So basically, you want to take the first term and you want to execute it recursively, and that will return some value, which we ignore. We don't really care about it. And then we're going to execute T2, and we're going to return the value of recursively evaluating T2. So sequencing, what it's going to do is, if you have T1 sequenced by T2 followed by T2, you're going to execute recursively first T1, and then you're going to execute T2. And the result of the whole sequence is the return value of T2, which makes sense, right? When you write code in Racket, you're going to have one expression and the second expression, and only the last value is returned. So this is what the rule esec is embodying, right? It's really just defining that notion. Okay, so now for a define, what do we do when we see a define? If we take a define, what we're going to do, the idea is we're going to evaluate this expression, right? And then we're going to somehow, in the current environment, which is given by E, we're going to update X with E, right? So let's say that before there was some value, now we want to update it to E. So how do we do this? Well, the way we do it is, first thing we do is we take E. How do we get E? E is the defined body, right? So we take the body, we recursively evaluate that, and that gets me a V. So let me store that in a variable. Let's call it variable V. Okay, so V, what do I do with V? V I'm going to plug in here. So this is going to be my second line of code where I somehow need to update the environment. So the environment is the same. This is like the scope. It represents the scope where a certain define is defined, right? So if you had some code, class cd work. Okay, so if I have some code, lecture 23, bracket. Okay, so if I have some code lang, bracket, and I have define x1, and I have define x2, y2, both of these two variables are declared in the same environment, right? So let's say that this is the environment, and I'm going to give you more examples clarifying this. So let's say the main environment, let's call it environment E0. So E0, here what I'm doing is I'm saying that in E0, now I have X. So let's say that my E0 now has that X is assigned to 1, and after this, in E0, Y is assigned to 2. So at any point, I can access these two variables. So let's say I had some definition F, and what F does is plus XY. This code should work, right? If I call it here, it should return 3, because it should look up on environment E0. Whoops, I forgot X here, X. Right. So after I do these two definitions, my E0 has X and Y, right? So when I call F, F should be somehow should have access to the environment which encloses it, which is E0. So because it should have access to all variables that are defined in E0, E0 encloses this whole thing. So here E0 is this, and here now there's an F, which we don't explain what it is. So here I forgot the F. Okay. So F is defined in this environment, in this broader, the outermost scope, which let's call it E0. And at this point, it has no variables. At this point, we define this function F. So we now have a variable F. After defining X, we have F and X. And after defining Y, we have X, X, and Y. When I call F, it is F because it was defined in the scope E0. It means that F can access any variable that is in this scope E0. So when we call it, we have X and Y there, and that's why we can return 3. So that's the intuition behind what we're trying to achieve. And what this operation is saying is that we're going to take the same environment and we're going to add X equal V. We're going to make sure that the new value is there. Okay. So now let's look at expressions. And expressions are very close, very similar to Lambda E and also Lambda F, with an exception being function application. So let's look at the first 3 rules. The basic idea is that when we execute a value, we should return the value. So same, this is a base case. This is another base case, right? These 3 are base cases because they're not recursive. And if you're doing homework 5, you should start by base cases because you already get a few points. So when we have a variable, we again should look up on the environment. So we have to look up in the shared memory. We have to see, where is this environment E? Give me the value X of it. So somehow we have to represent this, which is not implemented in the same way as we did in Lambda E. Okay, so this is going to be slightly different, but the intuition is the same. You're trying to achieve the same thing, but now you have to access some notion of shared memory. Okay, the intuition is the same. So the first 3 rules are exactly the same as Lambda E. When you get a function declaration, you have to create a closure, and you have to create a closure that accesses E, right? The enclosing environment. So that's why F is able to access X and Y because they're all in the same environment E0, and F has access to E0. Right here we're saying that we're using the same environment that encloses the lambda. Okay, so now let's look at function application. Finally, function application works very similar to Lambda E. Let's see. recursively evaluate the function, and you get some value. It's called VF. And this VF, as we know, is a closure, where EF is the environment, and this would be the function, the declaration that we have. Next, we evaluate the argument as before, and we get VA. Let's assign this to VA. Finally, we have to do this, and this is different, and let me explain what it means. Recall shared memory and heap operations. This is akin to allocating a new environment, right? Because intuitively, what are we doing? The idea is we want to be able to, when we run a function, right, we want to call this function, right? And as we know, this is a lambda x. It has a body, it's called a T of B. And it has access to an environment, E of F. So in this example, the environment is E0, right? The environment that that is enclosed to F, right, would be E0. But the idea here is that when you execute a certain function, you shouldn't mutate the environment that is enclosing it, right? When I create, if I define a variable here, let's say I want to define Z to be 10, right? What I'm trying to say is that after calling 3, I don't want to be able to access, so Z should not exist here, right? At this point, outer point, where we are in E0, when we call a function, it shouldn't declare variables outside of this scope, right? Here we should have a new scope, right? We should have an E1. So this Z is defined in E1. It should not be defined in E0. And basically, that's the key point to have in mind. So what that means is when we want to call a function, right, where we are going to essentially do substitution, right? Now, because we are doing mutability, we have to be very careful, and we have to take E of F, which is the environment of the lambda, right? And we have to create a new environment. And what this array is saying is I'm creating a new environment, and I'm going to call it E of B. So think of it as allocation. So I'm going to allocate E of B, a new environment, that takes all variable bindings of E of F. And I'm going to add a new binding where X is assigned to V of A. Where do I get X from? From the closure. Where do I get V of A? From the recursive evaluation of this. So that's how you get this new environment E of B. And then what do you do with E of B? You are going to recursively evaluate T of B. What is T of B? It's the body of the lambda that was obtained from the closure, that was obtained from recursively evaluating E of F. So I'm going to take T of B, and I'm going to evaluate it with E of B, right? So I'm going to take this environment, and I'm going to evaluate that. I'm going to plug it in as the input of the recursive evaluation of T of B, and that's going to give me some value, VB, which I'm returning it ultimately. So one thing to be mindful is the way you implement these 4 commands, the order in which you execute them has to be left to right. In Lambda F, you could implement it in any way as long as you have access to the variables. But here, there is a notion of side effects, right? So you want to first execute E of F, right? And you want to be able to assign this value here, but this E of F could be the outside scope, could be equal to this E, which means if you allocate this somehow before if you flip the order of these two, then the execution of this variable, right, might not have been available here. What does this mean? It means that if you were able to somehow change the argument, mutate the environment, if you reorder these two, that means that EF will not observe side effects that came before it, So in this case, you wouldn't be able to do it because v of a, you need this value, and to get x, you need to get it from here. So I don't think here is a problem, but in principle, I just want you to be mindful that the order of these three things have to be, first you have to execute this, and then you have to execute that. Oh, actually, I see where it matters. It matters in these two, actually, because this is using E, and this is using E. The order in which you evaluate each of these does matter, and you have to be careful to not reorder it. Okay? Regardless, implement it in the order that is described here in this from left to right. Otherwise, you might have very hard to debug bugs. Okay?